Am I live? Let's see that quickly. Am I live? Good. Alright, seem to be live. Welcome back, people. Today I'm going to do lookup tables, something that I haven't done ever. It's the first time I ever do this, and I'm going to be trial and erroring this, but I don't know, yeah, I think I have a more or less good idea. Let's read something about a lookup table. Well, I know what a lookup table is. Well, okay, so a lookup table basically will save us the hassle. Well, the data has to be stored somewhere, but it saves us the hassle of writing a lot of if statements and a lot of codes and like, it doesn't look so good. I mean, let me show you how I handle, for example, one case of, where do I put this? Where's update stove? Should be here, right? Update mixer. Update mix. Where do I have that in update? Oh, it's, yeah, there it is. You see? You see this much? All of this is just handling two elements. All the case for them. This is not sustainable. It's stupid, and if I'm going to write it, I'm going to hate myself, and it's going to be very unreadable code. The better way to do it is have a lookup table. A lookup table would handle all of these cases. Let's work on that. So let's say, for now I'm going to write it here, I'm going to move it over somewhere else. So let's say we have struct mixer case, right? And it will have a result. It will have an element slot, which is the result. So element slot result. It will have I think like types, like what's the opposite of products? Reactant, well, oh, not ready. What? Reddit. Never mind. I don't know the German one. It's Edukte. What's an Edukt? Produkt. Reagent. Educt? Reagent. I like reagent. Alright, so I need an enum type called reagents. So enum reagent cases, reagent case, reagents case, and it will have, well, let's start with one, which is water saltrium. I also have to keep in mind that sometimes, like water saltrium equals saltrium waters, it's the same thing. So we have water carbium and saltrium carbium. Alright, these are the cases. Because it doesn't matter what you put in a mixer, it mixes them both. So we have an reagents case called case, and how do I deal with how do I deal with the stuff? Wait a second. How do I deal? The amount is over 0. That's a case, of course. Now this will give us a case. Alright, so actually this could work, because if the case is water saltrium, then first one, second one. So we have then element slot A and B. These are the reagents. They have also because I'm gonna have to write this more or less, like all the different, and we have a ratio. Ratio is, yeah, float called ratio, and that's probably it, right? We have ratios, their temperatures. They should, wait, I might get my, hold on. You order a couple of things on Amazon, they never come together. They're always kind of like one today, the other one tomorrow. Well, they do come together if you order them at the same time. Not all the time, but sometimes they do. Never mind. So, okay, so we have that. Temperature, all of these things. Now, that's it. That is basically it. Now, I need to also store the cases. This is where I need an array of mixer cases. I need somehow to sort them, right? It's gonna be a linear search mostly, but that's what I'm doing here either way. I could also store them based on reagent cases. This way I will keep things, you know, a bit more organized. I can read. Yeah, I think I can read this. Can you read this? We're online, right? Right. 0 drop frames. That's the way I like it. It goes on and on. Alright, so I can. Way too small. This is good enough. Okay, so reagent cases. Okay, so we have that. Now let's initialize the cases, I guess. Alright, so I'm gonna write a function called okay, I gotta look this up. Yeah, but how do you do window new window? Maybe it has a view. Control Shift P. Really? Oh no. Okay, Control Backspace. There it is. Oh no, okay, Control Shift P and then add another command. Okay, so we have that. Now let's write a function and call it void initialize mixer cases, and it takes a pointer to mixer cases, right? Which has a bunch of those. So let's say mixer there's like an array of those, and I. That's it. So it takes mixer cases. Okay, so here, let's initialize the cases. So cases.c of cases.c equals mixer cases pointer malloc size of mixer cases. Now of cases C, cases I, dot. Okay, I don't like this cases, cases, cases. Let's just make it. I'm gonna rename this to cases, big C, M. I like M. Alright, so MC of M. Alright, I gotta make also. I'm gonna be very. Int I equals the address of this baby. Alright, because I don't want to have to think about it. But wait, this will increment the pointer effect. I have to dereference it every time. You know what? No. Okay, so here, dot case equals water sultrium. The heat level of water equals 0. What else do I have other than the heat level? I have the amount, right? That's it. That's basically it. Alright, so okay, so B dot heat level will equal 0. You gotta do it hierarchical, I think, because I don't want it to just go in a linear search that does not make any sense. Well, if it goes through the first one, like it checks what's the major case, then I can group it into this one. Now, if it's gonna have to check like what heat level is 0, then it's narrowed down to the first 5 or something. But I have to also point it to the one. I need to memorize the I that starts, like I need to put indices. Wait, let me write this down because I gotta go to the toilet. Bookmark indices. This is a good idea. Bookmarking indices is actually a good idea. Alright, so I'm gonna be right back. Alright, so we're back. So here I want to bookmark indices. Bookmark's gonna take a while later, but for now let's do this. 0, 0, I have ratio. Alright, so ratio can have 3 levels, 0, 1, and 2. Int ratio level. Okay, so there's a lot of information that I don't need here. So I need, I don't need elements slot AB. I need heat level AB, heat level A and B. So here is going to be an int heat level and element type. It's going to be a result. So in this case, it's going to be just the heat level, there is a ratio level, and then type is gonna be low density sulfuric acid. Right. Now if I take the same thing, go on it down. Now the ratio level is 1. It's going to be sulfuric ice. How do I deal with the ratio levels? That's the thing. Sulfuric ice. E3. Oh my god. Yeah, I can't wait until I get like an HDMI splitter, and I'm gonna move this over to the better computer, because what the hell is this? What are you doing? What are you doing? It just is just killing itself. What are you doing? It didn't do anything. It didn't do anything. Heat. I could have done it myself until that point. It's pointless. What's this slow? Still didn't do it. Wow. Okay, let's do. Okay, so we have this. Ratio levels. So let's say the ratio is 0.2. How do you know? Well, I can make ratio caps, right? So like up until this level, you'll do this. That would make more sense. So let me rename ratio level to ratio cap. Yep, so we have ratio cap. In this case, the ratio cap would be 0.3. Here it's going to be 0.6, and here it's going to be 1. That makes more sense. Good. Now let's make the same thing, but with sulfurium heat level 1, and it's gonna be this one, and diluted sulfuric acid, concentrated sulfuric solution, concentrated sulfuric solution, and we have, of course, a very concentrated sulfuric solution. So this is 0.2. Up to 0.3, 0.6, and 1. Okay, this is pretty fast. Yonder, get out of my mind. Yeah, song, get out of my mind. Alright, so we have diluted sulfuric acid, concentrated sulfuric acid, and very concentrated sulfuric acid. This was when heat level was 2, 2, 2, 2. Now keep in mind, the lookup tables are gonna be, like, defining this is gonna be long anyway. You have to put the information somewhere. But it's much better to put the information where it makes kind of sense, like separate, that you import it. you could also put this in a spreadsheet. Like, it's not a, do whatever however way you want. But as long as you still put it in the main function, so the function just doesn't have to like be stupidly long. Like calculating the ratio shouldn't be something that I'm doing in every if statement, because it's weird. It's weird. And there's a lot of if, and all that I can just do in a lookup table function. Look up this, and it does that. I can add even parameters of what kind of thing it is, so it doesn't just go a linear search over whole. All this thing will just jump to the bookmarks of things that are. I'm really looking forward to the bookmark system. It will cut down on search time. Okay, so well, right now probably isn't measurable how much faster this is, but imagine you're doing this on a much larger scale where you're, I don't know, just better practice, I guess. Like squeeze as much possible as it can be squoze. Okay, so here we have a case where it's 3. What happens when there is no ratio caps? Like, what if filtering gas, for example? Maybe there's something called an amount multiplier, alright? So this is like, I don't know. Or multiply. This equals to 1 all the time unless specified otherwise. But it needs a ratio, like it needs to calculate the ratio. Like in this case, it's a little bit hard to do a special case. Because I don't know, because it's not logical, I guess, but alright. I could make it a rule, sort of. Let's say int multiplier and here float ratio. I only need the ratio if it's a special case, so here bool case equals false. These are all for a special case. So let's say in this case it's gonna be special case is true, and multiplier equals I don't know about this one. So if you fill it up, for now, it needs to point to the memory address of the mixer. So maybe in this case, ratio should be this. No, but it's not going to work because ratio is not a pointer. So let's make ratio a pointer. And multiplier equals the dereference of that pointer over 2. Not sure if this one works, but yeah. Alright, so here we handle the case of water equals 1. Still, that doesn't... so let's say int I, so A0 I is the first one. I need an A1 and A2 and A3. So let's put this over here. Sort them together by case. That would make sense. We'll loop over possibilities of things. So here, I'm going to replace this with this. Okay. And actually, I don't need any of those. Secondly, here, A0 of I equals M pointer I. Right? That's where the A0 starts. Here's the bookmark. Case is going to be sultry. mixer case. And we have a struct of all mixer cases. And this one will have mixer cases pointer okay. So we're working with mixer cases for now. If heat level is A0, this means 4 int I equals 0 and I increment. So I is less than 3. Less than 3. That should be at the very end. But here at least heat B will equal 0. Now here it starts at 0 and ends at wherever mi is here. Oh, it's gonna be a bit hard to make this work and still be now. If A equals 0, that happens anyway. Now. Work towards 3 cases, and also I'm gonna realloc 3 cases. So here, first I'm gonna realloc. The size is gonna be size of what was C? Mixer case times 3. And this needs to be cast, I think. Yep. Okay, so here I initialize 3 cases. First I store the there's a lot of hierarchies. I store the index, the bookmark, then I initialize here 3 steps, for example, and I have here 3 steps. Now I can actually make this even cheaper by expanding all of them, but I'll get to that later. So here we have the 3 cases here. And replace it with zilch. Alright, so we have starting from wherever the mi is right now until mi plus no. Here b is 1. Take away the b's. Here I add 4. 2, 3, 4. Actually, every one of those I need to increment this baby. Alright, so here. They threw it into the thing. Okay, so now I'm contemplating just actually moving this thing over to the other computer, but I don't know yet. Okay, so let's finish this one first. So we have this, it increments the cases, we have the wherever I was, and then plus 4. Good. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. 12 cases. I don't have to do anything about it now. Now I have these 3. Okay, so and then oh yeah, after I allocate the 12 I can actually push for the 12. Alright, so the next case goes the same way. Also 4, I think, yep. But this time b equals 2. So go away. Go away. Okay. That's it. Now here. Actually, I don't need this. Good. We have the A0 case. I don't know if it's really less. I mean, it doesn't look like it's less, but Okay, so let's make the level 1. So here it's going to be any. I see. It's going to be okay. Now the second case where a equals 1. 1 and case 0. Diluted Celtic solution. Celtic solution. You know what? Let's reduce the spaces between these things because you already can see them like it's not. Okay. Point 3, 0.35, 0.7, and 1. Next. Level is 1. Point 2, point 4, point 7, and 1. Point 4, point 45, point 8, and 1. Okay. Seems to be working really well. Like here, let's just make like this so that we have a divider. Divider, and then go like this. The next divider. It gonna be like that, that's the thing. But at least, well, it looks much here, it looks much there. I think it's still better to write this one because this way I have like at least a data set somewhere on memory, and here is just I'm reading it off code and it's going to be weird. Especially since there might be a lot of mistakes that I make on the way, and that would also put things over. Alright, so let's do the A2 case. So one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, my dude. It'll be 13. Okay. So 0. Ooh. Okay, so the last one, no, it's not the last one, it's number 2. So heat level 2, heat level 0. Diluted. Salt rich solution, very concentrated salt solution. The numbers are going to be 2, 3, 6, and 1. It's going to be the same thing here actually. Heat level 2. I see. That's what I was talking about. Not making those clumsy mistakes. And the code breaks. And then you ask yourself, Ma, where's my code break? Well, this is why. You're a fucking idiot. That's why. 4, 4, 4, 4, 4, 3. Oh. I think there's 13 in this case. Oh. Zero, 1, now 2. Maybe 0.2, 3, 6, and 1. Now there's a 3. Gonna the multiplier is gonna be this thing. It doesn't have a ratio cap. So that case is gonna be 1. Or whenever I initialize it, no. Okay. Last case. So here we've got 1, 2, and 3 actually, that's it. So 3 plus, I need this. They're all gonna be special cases actually, so I'm gonna need this. So heat level 1, actually not 3, 4. Heat level 0, 1, 2, and 3. So they're all 0 and 1. Give me a sulfate solution. Times ratio. That's it. Heat level 2 will give you a sulfuric acid, which also multiplies by ratio. Heat level 3 multiplied by ratio gives you gas. That's it. 1, 2, 3, 4. We have 4. They're all initialized. And here is A level 3. Now we have these bookmarks, of which A level we are. Now I can either put them into mixer, like I can either put them all into the cases, into this one long ass array of things, which is fun, I think. Water Saltrium. So maybe a water Saltrium case. So I just need them to tell me. Alright, let's do it like that. Let's put them all into one string, into one array. Let me remove the cases and instead do in this mixer marks. So here I will store those things, and I'm going to store The I of it is the A0. Alright, so mixer. It will have all these things. It will then have races. Nice. All right. So I can find. Or if I just do. Can I do this? Yeah, I can. Although we don't have a problem. Alright, so here. So we'll look up mixer cases, which has a mixer case. Right. Good. Now I gotta rename all of this because it's weird. Lookup. Oh. And this, and basically this, and this, and replace it with this. You passed the whole lookup table. Yeah, I think so. Equals lookup dot. There is nothing inside of it. What is inside lookup? All right, so it's gonna have bookmarks or software. There is bookmark, not bookmarks, water software for now, and Saltrium. Water Saltrium. Okay. So here let's say init water Saltrium. Equals lookup dot cases of water Saltrium. The address of that, and these are all going to be pointers. So actually find this and replace it with this. 2, 1, 2. Equals the address of the lookup C L, and you just copy them. No, they're not pointers, they're just normal values actually. Okay, I think this is it. I'm not sure, but I think this is it. Well, alright, I don't know, I'm still on the fence on the idea of how to store the bookmarks, because say we have a lot of cases. Actually, I could do this. Struct page, and inside of this page I will put bookmark, B, and cases C. So like inside of these pages, that's all. And do you have an array of pages on this? Here I think you need the cases, the enum thing, the reagent case. Okay. And you have page array. Yes. So here you go into relock this thing and size of P of lookup I equals, now here dot case equals water sultry, and the cases will be lookup there you go. That's how you initialize the thing. And after you're done with everything. Not here actually, there's not much to be changed after you assign these things. Increment it. You assigned a case, you assigned a cases, and you assigned a bookmarks. And here you set I to 0. And every time you add another page, which will have reagent cases. Yep. I like this hierarchy. I like this hierarchy. Now this is just the initialization part of things. This is where I store things in memory. There's another difficult part, not difficult, it's just a lot of writing, is to actually, not parse, but deal with this. To check the actual looking up function of things. As you can see, like the size doesn't look that different, but it's just that here, there's a lot of more words. Space-wise looks the same, but there's a lot more words in this, and there are a lot more functions and if statements and stuff, which is a lot more calculation. Not more importantly, but it's the most important thing is that there's a lot more calculation than that one, which is bad. Here has less calculation if I do the lookup thing right, especially with bookmarks. Using bookmarks to jump to the right eye would save us a lot of computation time instead of a linear search. Secondly, there's a lot less ability to make mistakes if I run this right. If I write this right, that's just a template that I just copy and paste. Here, there's a lot of ifs and whatnots, and it's weird. So there's that. Anyways, how do I block these people so that they would stop bugging me? Well, not bugging me exactly. They're just writing. So there's that. Now let's the only thing that I just don't like that much about it is that This is very specific. Like this function is not a template. It's specific for water and salt trium, which there has to be some specificity to it. So, but yeah, that's good. Need to get the struct. Integers, pointers, integers, pointers. There isn't much. There isn't much in it. Element type. Okay, so what I'm gonna do next is I'm gonna stop the stream for now, which has been running for an hour and a half, and I'm gonna go down and get my wire to actually connect this, migrate this project to the bigger computer so that we can cut down on the computation times, on build times, on even like make it a little bit higher than 10 FPS maybe. I don't know. We'll see. So thank you everybody for watching, and I'll see you maybe next time.